Good afternoon, everyone, respected authors and invited guests. Welcome to the technical session 11E. Myself, Gayatri Bhuvan, and this session would be moderated by me on behalf of Global Knowledge Research Foundation and the Scholastic. It is my great pleasure to welcome you all to the 10th International Conference on SMARTCOM and Computing for Communications, SMARTCOM Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held today in Pune, India, and the virtual event is being held through Zoom from 19th to 21st January 2026. I hope you all will enjoy the knowledgeable session. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answer. I will give a gentle reminder when the 9-minute mark reaches. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any kind of query or update, you can text me in the chat box. Just before we start the session, I would like to introduce you all to today's session chair, Dr. Ramchandra Mangorkar. He is an associate professor in the Department of Computer Engineering at SPKM DJ Sangvi College of Engineering, Mumbai, India. His areas of expertise include blockchain, information security, delay-tolerant networking, wireless networks, and cryptography, with a strong focus on secure and resilient communication systems and emerging technologies. So, would you like to address the participants?
Hello.
Right, sir.
Yeah, you can continue, please.
Okay, sir. Now I'd like to.
No, actually, you are not audible properly.
Hello, I'm audible now. No, I'd like to call upon the first presenter now. Jeevit Gowda RM sir to present his paper titled AI-based traffic management system detecting emergency vehicle. Over to you, sir. Sir, are you present? Okay, we can move on to the next presenter. Sonali S. Gaikwad ma'am to present a paper titled AI-driven summarization of audio and video using speech-to-text technology. Over to you, ma'am. Since ma'am isn't responding, we can move to our next presenter. Manjunath Naik V. Sir, to present his paper titled Analytical Study of Clock Tree Synthesis and Clock Tree Based Design Approaches. Sir, are you present? Next presenter. Madhigowda BK Sir, to present his paper titled CNN Based Wave Detection and Geospatial Judgment Recommendation for Sustainable Environments. Over to you, sir.
Okay. Good morning, everyone. Respected chairperson, honorable panel members, and all participants.
Sorry for disturbing. So my laptop was in problem, so I just joined now. Please, chairman sir, dignitaries, can you replay it?
Yes, we can present after the current presenter.
Okay, sure. Thank you.
I am Madhigowda BK from ATME College of Engineering. Today I am going to present a project titled CNN-based waste detection and geospatial dustbin recommendation for sustainable environment. With rapid urbanization and growing waste production, effective waste management is a critical challenge. Our system addresses this issue by using CNN to classify waste and geospatial techniques to recommended nearest bin by searching database of the dustbin locations. This integrated approach helps to improve waste segregation efficiency and promotes environmental sustainability. Public data sets are available for waste images to classify waste and to build a CNN model, which are used to train the CNN model, but no standardized public data sets are exist for dustbin locations. Hence, a custom geospatial dustbin database was created manually using dustbin locations. Objective of our project is CNN based waste classification, which designed and implemented the CNN model to identify and classify the different types of waste, which are dry and wet waste, from the image uploaded or captured. The second objective is dustbin recommendation. Develop a GPS enabled model to identify and recommended the nearest approximate dustbins and user friendly web interface for the image uploading and output retrieval. Existing system is manual waste segregation and manual dustbin searching. So manual waste is collected and manually sorted at recycling plants. And manual dustbin searching requires user to physically locate suitable bins, which is time consuming and often inefficient. Limitations are inefficient waste classification, lack of real-time monitoring, difficulty in adapting the dynamic waste generation. Proposed system. We divided this project into two models. The first model is CNN based waste classification model. The input of this model is an image of the waste captured by or uploaded by the user. So image processing, this model will process the input image to enhance its quality for classification. Machine learning classification, CNN model will be trained on large and diverse data set of the image of the types of waste. The model will be trained to accurately classify the waste into predefined categories. Output is the type of the waste. So along with the type of the waste, we have giving the proper disposal methods, instruction on how the specific type of waste should be disposed, and recommended bin color, the standard color coding for the waste bins relevant to that type of waste. Nearest recommendation model, this is the second model. So input is user current locations and dustbin data management. A data set will store the information about the location which are manually created a custom database. Recommended algorithm, distance calculations algorithm, and ranking and selection. We are using a sorting algorithm. Output is the distance of the nearest dustbins. Software requirement. The first module software requirements are the deep learning framework. We are using a TensorFlow for building and training and deploying the CNN model. Programming language Python for CNN model development and the backend services. And image processing libraries OpenCV for image pre-processing and PIL for image loading and manipulating. The second module, dustbin recommendation module, software requirements are geospatial dustbin calculation, which is aversion based geospy distance and geostick.
Excuse me. Can you focus on your results, please? Algorithms results. Your contribution.
Okay. So this is a result which is essence an input interface for the waste classification model. So here we can upload an waste image or we can capture the waste image. So once we are uploaded the image, click on analysis, which analyze the waste type, wet waste and the dry waste with the percentage of the confidence, and recommended the bin color. Below that we have detailed analysis report, what image consists of and all. So this model is developed by the CNN model by training the large data sets. This is the dustbin tracker result. So here user location is taken, and here is a map interface where the dustbins are located, and these are the nearest dustbins from the user's location. So here we are using the two algorithm. First is geospatial distance calculation algorithm to calculate the distance between the user current location and the dustbin's location. Another one is sorting algorithm. We are using timp sort to sort an algorithm in a increasing in ascending order. So it is an ascending order which suggests the nearest dustbins. It is the knowledge center which provides the knowledge about the recycling, composition and waste reduction, waste segregation awareness. Then future enhancement is expanded waste categories. So we have just including only dry and wet waste. So we can include more waste types such as e-waste and other construction waste and all. Provide more accurate classification and disposal guidance. Next, proper feedback mechanism allow user to report unlisted or mismanaged bins for maintenance updates. Municipality system integration connect with the city waste dustbins for synchronized collections, schedules and analytics. Multilingual support to encourage regional languages, and we extend more data sets and with real-time segregations. A conclusion of our project is by implementing these two models, we can improve sustainability and reduce manual efforts and reduce manual searching of and dustbin locations. That's thank you.
Yeah. There is one question to you.
Okay, sir.
When we segregate this dry waste and wet waste, so how the system is going to detect it is dry and wet?
Sir, we are training the model, CNN model, by using different types of waste which are included inside it. So that's why.
No, but segregation, how you are moving for segregation? Because most of the the waste material is mostly categorized into dry waste. Okay. So how your system is categorizing by looking towards the images?
Sir, here wet waste is in this image. Wet waste is considered as a water which has been included, like water, moist content, and some dry waste categorization are we
No,
are
in
included in that one.
in this image, if cup contains some of the liquid part, like tea or coffee, a small part,
Yes,
even
sir.
though it is so it will be categorized as dry or wet. How your system will uh, detect, means whether
Sir,
it contains some liquid part or not? Yeah.
sir, our system detect it as a liquid content, but it has considered as a dry waste because it has the liquid and moist content, and a plastic cup was considered as a dry waste.
Okay. Okay. And what is the accuracy level that you got? And how many test cases you considered?
Sir, accuracy level, we have got a good accuracy. With here we have the confidence accuracy percentage for a wet and dry waste.
That is
So
47%. That is a confidence value, na?
yeah, sir,
So
confidence
what
value.
about false positive, false negative? Means how many images it can categorize as false and true that you analyze?
No, sir.
Okay, so I suggest you to do that also
Okay,
and
sir.
increase the number of test cases.
Okay, sir.
Okay, so good work. Congratulations.
Okay, sir.
Yeah, thank
Thank
you.
you, sir. Thank you,
Thank you for
everyone.
presenting. Thank you for presenting. Now I'd like to call upon our next presenter, Givitoda R. M. Sir, to present his paper titled AI-based traffic management system detecting emergency vehicle. Over to you.
Thank you, ma'am. Good afternoon for one and all who have presented in this presentation. So let me share the screen now. So let me introduce myself. Is my screen is visible? Excuse me.
Yes, it's visible. You can start.
Yeah, our team project name is AI-based traffic management system detecting emergency vehicle. In my team, there are the total 4 members: Ishak Faris Gaima, Niranjan HM, and Raghavendra P. And I'm Jivit Godariam, serving as a team lead. And our guide is Professor Yogesh from ATME College of Engineering, Mysore. Let me take him to the abstractions of our project. So this project will explore the AI artificial intelligence to predict the patterns, the congruence of the urban areas where analyzing the historical traffic data and generate a green signal. So let me come to the introduction part. So as this is a rapid growth, as in the rapid growth, as in a rapid growth of development of AI-based traffic management. So in urban areas, they are getting a lot of traffic and so on to reduce to give our optimized traffic flow to the people where the populated area is there. For them, we have developed this kind of AI-based traffic management system while detecting the emergency vehicle. So if I come for the next slide, which is a next slide is existing system. So in existing system, there are the big data analytics. In big data analytics, collecting and the processing, and intelligence dispatchal systems and traffic management system. So in existing system, we are getting only the traffic flow, generating the green signals for the heavy traffics. But our project is aimly to detect the emergency vehicle and generate a green signal. So let's move on to the next part, which is a problem statement. I will come to the direct view of our problem statement. So in this current scenario, the people are facing in a lot of traffic issues. So let me take an example of use developed cities like Mumbai, Pune, and Sohan country. So Sohan state or Sohan districts. So in there and all, there's a heavy populated. So think if the ambulance is stuck in between the traffic, means it's very tough to clear that particular lane. So for this scenario, we have developed one project where it called as the AI-based traffic management system detecting emergency vehicle, where the camera is going to detect the ambulance and generate a green signal automatically. So where the police involvement is less, and it useful for the people also and societies also. So this is one of the main problem statement. And our objective is, first we are going to take an historical data set and we are going to analyzing it. After analyzing with suitable AI models, they are training and we are developing through the AI models. After that, and it provide a accurate forecasting aid of the time management, where it generate a less time second of green seconds with a less number of vehicle, and generate a green signal seconds with the I number where the vehicle count is more, and it generate a automatically green signal if the ambulance is detected in the far of 100 meter away. And next is a literature survey. These are all the literature surveys what we have taken. The main gain of this literature surveys, we taken the gain that how we want to train the model and how we want to stick on to the particular algorithms and how the decision is making and how the signal is generated. So these are the 4 features that we have taken from the literature survey and the IEEE papers. And next, if I come to the proposed system, so this is what our entire proposed system of our project. First, we are going to detect the emergency vehicle via cameras and it generate automatically green signals. And second is bidirectional. So why we designed this bidirectional in the sense means, what if in the case of 2 ambulance appear in 2 opposite lanes? So for this scenario, we generate a green signal based on the vehicle count. If the vehicle is less, the green signal will be generated later, because it's a common sense that the people will leave the ambulance for the if the vehicle is less. So think if the ambulance is heavy or more vehicle, so for that particular lane, we are going to generating a green signal automatically first. Next, we are giving the green signal automatically to the second. And third is web application users. Here, this predict the area and it predict in which lane the traffic is more, and the user can take or the user can fetch the data from the this website. This is what the three main features of our project, and we are proposing it. And if I come for the model system architecture, first in methodology, so we have taken the data sets and we have pre-processed it. And due to the clustering, we have developed the models and probabilistic reasoning and shallow machine learning. So machine learning models also we have used. So beside that, we have seen a system architecture where this system architecture tells about the 2 lanes, but we have designed for the 4 lanes of the traffic signals. So we have taken the AI suitable models and we have trained it, and based on the volume, based on the density, based on the speed, the green signal is going to generate it. And if I come for the hardware and software requirements, so we are the software CS students, so we have developed the system through showing the output through the simulation way. So here we have not installed any cameras, but we have installed a camera fed word in the Python libraries, and we are going to show the output through the Py games, where it is one of the extension of the Python libraries. And libraries are TensorFlow, and we have used a Yahoo model, you only look once model, to train it and to detect the object, that if the object is ambulance, or if the object is bus, bike, and so on. And this is what our workflow. So in this workflow, it's completely tells about of our entire project. First is web applications for users. First, the login credentials, and we need to select the one particular area where the traffic is more, to detect or to predict the traffic. So if we select one area, like example, I am in Mysore, I selected a Bunny Mandap. So if I select the Bunny Mandap, it shows the entire traffic density, where in which lane is having high density of traffic and which lane is having low density of traffic, and it shows the 24 hours forecasting of future 24 hours predictions also, and emergency vehicle detections. So yeah, that I already tell. So the camera will detect the ambulance vehicle automatically and generate a green signal. So where it reduces the time complexity, time consumptions of ambulance vehicle.
Can you focus on your results, please?
Yes, sir. So in result, I have added only the 2 more photos. If you okay means I can show the output. Can I?
Yeah, please.
Thank you, sir. This is our last feature of our project, that is website. So in this website, we have login, sir. We have belongs to Mysore. So these are the areas. So I'm going to selecting a Bunny Mandap. Okay. So we have to view the detailed status of Bunny Mandap. So it shows that all 4 lanes are having moderate traffic flow. Okay. And if I want to search through the map, so we have connected to the Google map, it shows the all 4 lanes of the Bunny Mandap. And if I want to go back it, so 1 minute.
You got your Google API key? So it is fetching live map, right?
Yeah, live map, sir. If I want to view the analytics, means it show the analytic of that. See, sir, from Jan 15 to Jan 21st, it shows the analytic ways. And if you want to upload the new data, see, these are the peak traffic whale density will be at 20 that we have developed for the 24 hours. And the average density will be 60.2 hours. And if you want to upload the new data, so we need to download the sample lane. So sample lane I've been downloaded here, and it is in an Excel file. 1 minute, it is showing. So in here we need to add the circles, area circle, and lane 1 ka position, and time density, and vehicle count, and so on. We need to fetch the data from the police stations, traffic police stations, and we need to upload it. After that, if you want to predict for the future 24 hours. See, I have selected a Bunny Mantap, and 24 hours, see, in morning 9 p.m. the traffic flow will be high, and in 5 p.m. the traffic flow will be high, and remaining it will be low, medium. This is what of the third feature of our project, and it shows the weekly traffic patterns, and we can log out. Okay, this is our last feature, and our second feature
It,
is
okay. So is it possible to update it dynamically? Means, for example, if a customer, if you are using this particular app and you are getting some obstacles or getting some traffic, so it is possible to upload this data
yes sir,
immediately
yes sir, it's up, we
so
can
that
upload
the
it.
other customers or the other will get informed in advance about this topic.
Yeah,
Is
it
it
will
possible?
it possible, sir. So it's still we have developing. This is our third feature, but our main feature is detecting the emergency vehicle. So where we here you can see. So 1 minute. See, so first, based on the vehicle count, the traffic flow will be generation of green signal will be generated. Okay, this is our first feature, and detect the emergency vehicle. Emergency vehicle will be detected and it generated the automatic green signal. And this is a
Okay.
bidirectional way. For this, we need to if you run the project means here it will take some the 10 seconds to download the packages. So after 10 seconds it's taken the PyGames. It is one of the extension library of the Pythons, so where we can show the simulations development through the Pygame itself. So we have taken the Pygame as a main features to develop our project, and it is downloading the Pygame community, and we are running through the Python 3.12. This word, and here if I want to say the if I want to show the accuracy. So for this we have we have trained this model, so for the simulation, and the images are there will be a four kinds of images, sir. That is left, right, down. That is like in four lanes we are having different kinds of the vehicles can move in different paths. So for that path we have trained it the models.
So paper ID.
So paper ID 931, sir.
Anyway, okay. So I know your system is running very well. And what is the accuracy level and how much percentage and what are the obstacles that has been detected or that has been is there any particular categories of detecting the obstacles? Only vehicles it is detecting or
And only vehicles, sir.
only vehicles? And
Yeah.
it is providing a, let's say, green corridor for ambulance or emergency vehicles, right?
Sir, actually, in the ambulance vehicle can be detected because based on the plus mark, and we have
Mm.
taken one image I have shown
Mm.
it,
No, that's fine. That's fine. It's
and
okay.
in that we are going to developing it. It detect on first we have developed only for the ambulance. Further, we can further extension is for the finding the what this one, sir. Fire extinguisher vehicle also we can
Mm.
detect it and generate a green signal automatically. So for that also we can be develop the future enhancement, and future enhancement can be also the main thing is if we can we can implement in a real scenarios where the camera can be fetched, sir. Like a camera can be installed in the signals far from 100 meters or 200 meters away, and that cameras can be detected the emergency vehicle and generate a green signal automatically. Just a minute,
Okay.
I just want to download the packages, so it's taking the time.
No, it's okay. Okay, no issues for that. Others are also waiting for this.
Okay.
Anyway, congratulations. So you have done good job. Best of luck.
Thank you, sir.
Yeah. Next,
Thank you for
please.
the presentation. And now I'd like to call upon the next presenter, Shravan Komadamo, sir, to present his paper titled From Traditional to Smart Banking Strategies for Reducing Problem Loans in the Digital Era. Sir, are you present?
You can announce those who are present. They can raise their hands. No issues.
Yeah, so let's look on the next
Yeah.
presenter. Running is required now. to present a paper titled Graph Theory Intersects with Cryptographic Algorithms in Design and Quantum Computing Context. Survey. Over to you, Ma. Are you present?
Next.
Good morning, sir.
Yeah,
Good morning, sir.
Start with
Just
you are not audible.
I'll
Yeah, please continue.
1 minute. Yes, sir. Good morning, sir. I'm audible.
Yes, yes. You're audible.
Start with
Okay, sir. Just one.
Your paper
Okay,
ID
sir.
818.
So,
Okay. Please make it full screen.
yes, sir. 818.
Yes, got it, got it.
Thank you, sir. Department of Mathematics, Gupta Institute of Technology, Belgavi, and my paper theory intersect with cryptography algorithm designed in the quantum computing context. So next is the index of the paper, which all to cover in this, that is foundation of graph, theoretic construct cryptography, post-quantum cryptography, graph theoretic foundations, quantum security models, and graph quantum hybrid protocols, and emerging research challenges and open problems, directions, conclusion, and references. Next, introduction. What I'm going to explain here, that is about the graph. Define the definition about pair of vertices and edges, and key spaces, that is spaces and security assumptions, resistance to show the intersection of graph theory and quantum cryptography is significant because graph isomorphism, graph coloring challenges, Hamilton paths, Tanner expander graphs. In next slides, I'm going to just explain, that is the second slide, that is the foundation of the graph theory construct in cryptography. Hello?
Ma'am, your
Hello?
voice is breaking.
I'm not audible. Hello?
Ma'am, your voice is
Hello?
breaking. Hello.
1 minute. Graph-based hard problems. Voice is breaking. 1 minute, madam. I'll just check. What is the problem? Voice is breaking.
Now you are audible. Please continue.
Graph-based hard problems with isomorphism,
Now again, not audible.
parts,
Your voice is breaking.
coloring subgraphs. So in this isomorphism lab itself, 1 minute, I'll check. Sorry, sir. Nah. Hello, sir. You can hear me?
Right now you are audible. Please continue.
Thank you. It is like isomorphism, Hamilton paths, coloring, and subgraphs. Here in isomorphisms and all, what we can study, how security can be provided using this graphs. So isomorphism is the main thing in this graphs, like two graphs, how they are interconnected to each other. Hamilton paths are nothing but the paths which are not the paths which are Hamilton paths, coloring, and all. Here the main thing is that here minimum colors are used so that the security can be provided more. And subgraphs are nothing but in subgraphs and all. Here in bigger graph, one graph is used, smaller graph is used so that the security can be provided more using this. Next is expander graphs and pseudo randomness. So in expander graph and pseudo randomness, in this expander graphs are nothing but the smaller graphs which have small connectivity, which have very strong connectivity. Even while removing the nodes also, they are being connected. That is one plus point of the expander graph. Next is pseudo randomness. Pseudo randomness in this is that they behave like a random graph, but they are deterministic, but they helps in generating the secure keys. Next is lattice graphs and lattice based structure. Here in lattice graphs and lattice based structure, here they are arranged in the form of a grid like structure. And next is here there is a equation used like ax plus e equal to b. That is nothing but that equation represent learning with error, which is very helpful for security purpose. Next is in the next slide, we can see the post quantum cryptography foundations here. In this, we can see the lattice based cryptography. Next is code based cryptography equations. In lattice based, as I have told you, sir, like it is here they are arranged in the form of grid, and here X plus C again learning with code based cryptography. Here their graphs are used with variable nodes and check nodes so that decoding becomes very difficult. Next is isogeny. Isogens errors are used so that here paths are very difficult to find. And next is multinormal equations. In multinormal equations, here the polynomial equations with Markov hash tree are used. And this explains about this post-quantum cryptography using graph this foundation. In the next slide, that is, I'm just going to explain about the quantum security models with a graph theoretic this. Here we can see that different types of model. That is, here first thing is that graph that is zero graph proofs. They are useful for the security of the graph purpose. Next, three coloring. Zero proofs are used because here many colors are used, but the collusion integration. So in this figure, the quantum key distribution, quantum key distribution is used, which is very one plus point for the security. Next is trust and verification. That is for correctness, whether the message is correct or wrong. That is used for this purpose. So this model gives a like a basic idea like how we can secure our this using graph theory approaches. This is very like important model for security purpose. In the next slide, that is graph quantum hybrid protocols and emerging researches. In this, divided like into three main this. First is expander graph consensus and JNN and quantum crypto analysis hybrid classical quantum models. So in this expander graphs, it is nothing again but the smaller graph only, but it has very strong connectivity. Because of this connectivity on GNN is nothing but the graph neural networks, which are very useful for any error detections and all. And next we have hybrid classical quantum models. So in hybrid classical quantum models have here the RSA and ECC that is combined with PQC that is key. And also you have here with the quantum key distribution, which is also used for which is also used for security purpose. In general, hybrid is a combination of is useful, like it is based for security purpose. And the next is like the challenges and the open problems in this are first is scalability, unknown quantum attacks, side channel, and the open problems. Here in scalability, the one this point is that the key should be larger and the key space should be more large. High CPU, there is a larger consumption. And next is unknown quantum attacks. Unknown quantum attacks means, as we know that the cryptographic algorithms are not known in future, so it might be possible that it is possible to be attacked in future, so it should be taken care. And next is side channel vulnerabilities. Side channel vulnerabilities means the attacks, like it can be through timing as well as power consumption also, that by that also the security can be leaked very fast. This is in the third slide, which I have explained about the challenges and the open problems. And the last slide, which is there about the future directions. For the future directions here, that is advanced graph structure, AI and ML integration, standardization and deployment, that is there. So in advanced graph structure, we have used like different varieties of graph, that are hyper graphs and dynamic hybrid graphs. And these are very useful for security purposes and all. And next is AI and ML integrations. AI, which is used for security purpose, and ML is useful for any error detection and all. So these are also useful for this integration. Next is NI, that is standardization and deployment. Standardization and deployment, that is NIST, is standardizing post-quantum algorithm. Hybrid post-quantum thus and classical system will be deployed. Focus is on real world and enterprising network. And coming back to the future direction, here I have taken few of the paper. That is first is analyzing cryptographic algorithm
Can you
One more
please
minute left for your presentation.
on results, please?
result. So
Yeah,
this
your algorithm.
graph theory unifies post-quantum cryptography by modeling
No, no. Can
hardness
you focus on
across
results, please?
lattice, code
Okay,
isogeny,
the
and
survey paper, right?
yes, sir. This is a survey paper. Hello?
Okay, okay. So what
Hello?
next? What next actually? What you are planning? What you are planning next?
So, means I'm planning for like it provides a framework for designing scalable quantum
No, but how you
resistance.
will plan to implement this quantum algorithm without quantum systems? Any plan for that?
So still I'm planning, sir, but still I did not like just this was a survey which I have done overall,
Like, but
miss.
see, to implement or to show the comparison between your work and the existing work, we need some system to implement the existing work. Okay. So
Yes, sir.
right now the computers, the quantum systems are not available.
Yes,
So
sir.
are you planning to put it on IBM quantum systems or something or else? What is your plan exactly to implement your concept?
So still I'm planning only, but this was the first time which I have done through the this. Still I did not
Yeah, yeah. Okay. So what are your takeaways after doing so much rigorous literature survey?
So I have what all I am going to do further like for research and all. I'm planning referring to all the papers using quantum theory and using graph also, which how I can link so that the security I can provide more security for that.
Okay. Okay. Anyway, good work. But just plan for how to implement this with quantum systems, okay, or
Okay,
without
sir.
quantum systems. So that should be your
Okay, sir.
focus.
Okay, sir. Thank you, sir.
Okay, thank you. Next paper, please.
Thank you for presenting. Now I'd like to call our next presenter,
My God.
Romil Agrawal Ma, to present her paper titled Hybrid Efficient Net BO and Swim Transformer Model for Diabetic Retinopathy Detection. Over to you, Ma.
Good morning, everyone. Myself, Romil Agarwal. Today, I'm honored to present our work, Diabetic Retinopathy Detection, a hybrid Bayesian transformer AI model. This research was conducted by myself and my co-author, Vatsal Agarwal, who is also in the meeting. Diabetic retinopathy or DR remains a leading problem due to which causes blindness among people who are more who are more sorry who are more sorry. Am I audible?
Yes, please continue.
So diabetic retinopathy is the leading cause of preventable blindness among diabetic patients, where early detection is very critical to get an efficient and better treatment. We have devised a hybrid model which combines swim transformers and efficient net B0 to detect the diabetic retinopathy and give early solutions to the doctor.
To understand this model, we'll first require to look at the problems in the current solutions. Uh, this the traditional CNN-based models face three major hurdles. First, they produce overconfident predictions without estimating uncertainty, which is dangerous in a clinical setting where a false negative could lead to permanent vision loss. Second, they suffer from limited explainability, operating as black boxes that clinicians find hard to trust. Finally, there is a severe class imbalance. In most datasets, models naturally become biased towards normal cases and perform poorly towards the clinically critical, severe, and proliferate cases. Existing CNN-DR detection systems are accurate on majority cases but unreliable and non-transparent and weak on advanced disease stages, limiting their real-world clinical ability. Our solution, a hybrid efficient net B0 swim transformer model. Our proposed solution is a hybrid framework that marries the strength of CNNs and transformers. We use EfficientNet B0 for its hierarchical feature extraction. This is where we capture fine-grained local lesions like microaneurysms and exudates. We then integrate a swim transformer to model long-range spatial dependencies. While the CNN looks at all the trees, the small lesions, the transformer looks at the forest. That means the global contextual relationship across the entire fundus image. This dual approach ensures that we don't miss any small details or broad clinical picture. Uh, the hybrid CNN transformer architecture helps us in robust learning under class imbalance. To address the inherent imbalance in DR datasets, the model incorporates class-specific data augmentation and focal loss, emphasizing hard to classify and minority classes. And the explainability for clinical trust is done using the GradCam, which is used to visualize diagnostically relevant retinal regions influencing model predictions, improving transparent and clinical confidence. By integrating CNN-based local feature learning with transformer-based global context modeling, the proposed hybrid architecture improves accuracy, robustness, and interpretability for DR severity classification. Key components, feature extraction of the DR classification and DR classification. EfficientNet BO serves as the CNN-based backbone, extracting fine-grained retinal features such as microaneurysms, hemorrhages, and exudates while maintaining computational efficiency throughout compounding scaling. And the swim transformer captures the long-range spatial dependencies using shifted window self-attention, enabling the model to understand the contextual relationship between retinal lesions across the entire fundus image. Uh, let's dive deeper into the components. EfficientNet BO acts as the backbone chosen for its computational efficiency via compound scaling. The swim transformer uses shifted window self-attention to understand how different lesions across the retina might be related. These combined features allow us to classify images into 5 distinct levels. These distinct levels are no DR, mild DR, moderate DR, severe DR, or proliferative DR. This classification is the foundation for our automated screening tool.
So data data imbalance is a very big issue in the medical data, which is due to which we don't have the extreme cases. We usually have most of the cases which are very mild or have the severe DR. So to address that problem, we used two pipelines, which was targeted data augmentation and focal loss. In targeted data augmentation, we more aggressively applied rotations and flips to the minority classes which were severe and proliferate classes to improve their representation. Secondly, in focal loss, we basically forced the model to focus on the not focus on the class which do not have many images, such as proliferate class, due to which we can get more dependencies on those classes rather than the classes which have more data sets. Secondly, we used overconfident we reduced overconfident misclassification by focusing learning on misclassification and underrepresented samples. The model mitigates the tendency of traditional CNNs to produce overconfident errors, due to which we can reduce the false positives in this. Next, addressing class imbalance. So this is what I told you already. We use targeted data augmentation and focus. Next, please. Explainability was a big concept in our model because doctors usually don't trust AI because they don't know how the AI gave the result data. So for explainability, GradCam. We use GradCam to turn the black box into a transparent assistant. As seen in our visualization, the model does not just give numbers; it highlights specific regions, as you can see in the heat map, where we can have the hemorrhage, and it also gives which class we have and where it is happening in the fundus image. So according to this, the doctors can see and have a second opinion without explicitly knowing what is the backend, and they can give the results. And we improved the focal loss and accuracy highly using this graph. Next. Conclusion. So the proposed hybrid Bayesian efficient model transformer used addressed class imbalance using focal loss and targeted data augmentation, achieved improved F1 scores as per the prior models which used only CNN. And we are hoping to get some clinical trials on this and improve the model and have a better data set to have better results. Thank you.
Thank you for your time and attention today. We are grateful for the opportunity to share our work on this vital project.
Just a question to you. How much accuracy you are getting and how the results are validated?
Sir, the accuracy is 91%, and we are validating it based on the previous existing CNN models only. Like what
No,
were the
but is it clinically approved? Because since we
No,
talk
not
about
yet,
the
sir.
medical,
It's the next
yeah,
step we are focusing on.
that is okay. But since the images belongs to medical data, na, so in that
Yes, sir.
case, you need that the data should be clinically validated. Means some doctor should approve it that
Yes, yes,
you are saying that you are getting this much accuracy, but since we are not from the that doctor medical background, so we
yes,
need
sir.
such people or such person who can identify and who can say that the accuracy which you are getting is a good accuracy level or your system is working fine. So for that purpose, we need somebody should validate this clinically.
Yes, sir. So we are working with a college on that. We are going to get a
Okay.
doctor, specialized
Yeah, and
orthopedist
this
on
data
this.
set you got from some medical institute or you tried it with the available data set on
The
Colab?
available data set.
Sir,
So
available data set
we are
after
working on
completing.
the updates that we will get. We have a hospital in contact which is in Delhi, which is willing to provide us the data set, given that our college mediates the talks and
So then that's good because if
yes, sir.
some my hospital is there, the doctor will definitely validate
Yes,
and
sir. So we are in talks with a hospital in
then it
Delhi.
will be a good work for you. Yeah,
Thank you, sir.
Yes, sir.
yeah. Okay,
Thank you
good,
for
Thank
good.
you, sir.
Thank,
Congratulations.
thank you for presenting. Now I'd like to call upon our next presenter. We are Kulkarni ma'am. to present her paper titled Modeling Subsurface Leakage in MOSFETs, Supervised Regression with Noise-Revised Synthetic Datasets. Over to you, ma'am.
Good morning.
Yes, ma'am, you're audible. Good morning. You may start present.
I can start, ma'am. Is it mine only now?
Yes, ma'am, you may start now.
Yeah, ma'am.
Yeah, good morning. Please share your screen. Yeah, visible.
Yes.
Make it full screen.
One second. I'm Dr. Trupti Kulkarni from EC department, working in Dayanand Sagar Academy of Technology and Management for Bangalore. Today I'll be presenting on modeling subthreshold leakage in MOSFETs. We are using supervised regression with noise-aware synthetic data sets. Paper ID is 950. Introduction is CMOS technology is continuously scaling nowadays, which has led to significant increase in leakage of the subthreshold current. So this leakage occurs when a MOSFET operates below the threshold voltage. So it is a major contributor to the static power dissipation in modern VLSI. So we have to go for accurate prediction of leakage current, and we need to design a low power circuit design. So we have gone for supervised regression based machine learning models, which provides an alternative for conventional analytic modeling. The problem statement is whatever traditional based models were there, they are not very accurate in finding the leakage current. So the sub-threshold leakage depends on many factors like threshold voltage, length, channel length, oxide thickness, temperature, supply voltage. And we'll be using SPICE simulation. We have used SPICE simulations and calculated the values. So ultimately the problem statement will be to develop an accurate and fast model to predict sub-threshold leakage current using supervised regression techniques. We have done a literature survey with all the machine learning languages and used in the VLSI finding out the leakage current, the subthreshold values. So there are many papers which we have referred. Like first paper is conventional analytic models, simplified assumption on lack of scalability, then VSIM models. That's the second paper, which focuses on scaling. Then recent studies have told that linear regression, how it is used in the leakage estimation, support vector regression for non-linear modeling, artificial neural networks in leakage prediction, random forest, how it is used to improve the accuracy. So from the literature survey, it indicates the machine learning based regression models for lower prediction error compared with the traditional methods. So this will be the abstract of whatever I have discussed now. So we have achieved the reduced error with 29.82% and increased error 66.67. It illustrates model bias variance trade-offs, sub-threshold slow prediction exceed the 59.87 millivolts per deck. So feature derived gate voltage efficiency improved from 0.667 to 0.702 volts per week. Increased off-stake leakage is plus 61.9%. So this confirms the necessity of incorporating additional features into predictive models for low power device analysis. So this is the methodology which we have used, data set generation using SPICE simulations, input features. These were all the features which I've already told before. We have taken them. Target output will be the sub-threshold leakage current, supervised regression model. In that linear regression we have used. Performance metrics is mean squared error and R square score. Results and discussion. Regression model successfully capture the non-linear dependency of leakage current. Machine learning models outperform analytic equations in prediction accuracy. Random forest SVR models show lower MSE and better generalization across operating conditions. Prediction time is significantly reduced compared to SPICE simulations. So the results demonstrate how feasible it is for early stage low power VLSI design. So these are the outputs which we have got, that is leakage current versus gate to source voltage VGS. After the calculations, we got this output: sub-threshold leakage current analysis, theoretical versus the practical. Sub-threshold leakage current characteristics. Blue is the theoretical values, and the green dot is the practical device with no noise, and red
Excuse
dot
me.
is the measured data.
Yeah.
Yes, sir.
Dr. Kulkarni, what is the major concern when you discuss this theoretical and the difference between the practical? Means why there is a difference between theoretical and practical approach?
Sir, that's what, sir. The error rate was more in the theoretical, sir. Now, practical is after using
More
these
or
machines.
less?
Yes,
More
sir.
or less, madam?
Yes, sir. So we tried to use the machine learning models, and error rate, we tried to reduce it, sir. That was our main concern, sir. Especially in the leakage current and all, very small values also matter a lot. So this is what we try to do it, sir.
Okay. Yeah. Please proceed.
These are the outputs using the linear model and residual for linear fit analysis, sir. And parameters also we have compared, and parameter error analysis is the first one is the parameter comparison, sir, theoretical and the practical using linear regression, and parameter error error analysis also is done from practical to the theoretical. So future scope is we did for a smaller data for machine learning and use machine learning languages. We can further go for the large data and use deep learning models like CNN we can use over there. And inclusion of this process variation and aging effects also.
Your data is structured, no? So why to apply DNN and CNN? Because mostly these deep learning models are only used in case of unstructured data like image, video, etc.
Correct, sir, correct.
So since you are talking about MSC, that is error rate and all those, so I think your data is structured.
Structured, sir. Yes, sir. Yes, sir.
Yeah. So I think this is not the future scope. Maybe. Yeah. So other you can discuss like how you can extend it.
Yes, sir. Yes. We'll just think over it, sir.
Yes. Yeah.
So these
Okay.
are answers. Thank you, sir.
Okay. Thank you. Congratulations. Thank you.
Thank you, sir.
I would like to call upon our next presenter, Sonali S. Gaikwad to present her paper titled Reducing Hallucination in Retrieval Augmented LLM Question Answering for Indian Code Mixed Queries. Ma, are you present?
Hello, ma'am.
Yes, you're audible. Sonali ma'am, you can start presenting.
Yes, ma'am.
Trupti madam, you can mute yourself.
Sonali ma'am, is there an issue while sharing?
Ma'am, I'm sharing, but some problem. Just wait, ma'am. Just wait.
Okay,
Just-
okay.
What happened?
Yeah, Gayatri, how many are remaining?
So one more presenter is left, and I think Sonali ma'am has two presentations.
Ma'am, my PPT is presentable.
Yes, ma'am, it's visible. Do you have two presentations?
Yeah, please go ahead.
Yes, thank you, sir. This is good afternoon, everyone. My topic is AI-driven summarization of audio and video using speech-to-text technology. So now I'm proceeding with my abstract. So today, I will be presenting our research work titled AI-driven summarization of audio and video using speech-to-text technology. This work addresses the growing challenges of extracting successful information from long audio and video content by combining speech-to-text conversation with the AI-based summarization techniques. So, here are some outlines of my presentation. So with the rapid increase of multimedia and content such as lectures, podcast, videos, consuming complete context has become the time consuming. So our society provides the AI-driven solution. The first converts speech into the text and then generates a concise summary. The proposed two phases approaches the significantly reduce the time required to understand the content and has the application in education and accessibility to content the management. I will explain the system of architecture in a two main phases of our approaches. Finally, I will discuss the experiment result, limitations, and future work, and conclude the presentations. The motivation behind this work is the massive growth of audio video content available in online phase. The key problem is that the extracting meaning of an insight from the long multimedia files manually is insufficient and the impractical. Hence, there is a strong need for the automated system that can quickly summarize such a content without losing the important informations. So my research objectives for this, the primary objective of the research to design the AI-based pipeline that converts audio or video into the text and then produce the accurate summary. Secondly, the objective include the supporting multiple input resources, reducing the content consumption time, and the maintaining the coherence clarity in the generated summarizations. The system architecture overview presenting the system architecture is divided into two main phases. The first phase focus on the speech to text conversion, and while the second phase appears a transform based model, the text summarization. The modular architecture ensure the flexibility, scalability, and easy integration of a advanced AI model. The speech to text conversation. In a phase one, the system handles the different input types such as the audio files, video files, and the YouTube videos. The audio is produced directly. Video files undergo the audio extractions, and YouTube videos use available transcripts when the possible. The chunking is a used to split the audio into the smaller segment, which improves the memory efficiency and transcription accuracy. Uh,
In a phase 2, the generate the transcript, the summarization using the AI models. We evaluate such as the BART and Gemini Pro. Gemini Pro selected because the produce more coherent, summarize, and handle long transcription efficiently. The text is segmented if necessary, summarized in parts, and then merged into the final summary. The web-based deployment, the system is deployed using the lightweight Python-based web interface, uses upload the audio and video files or simply paste YouTube URL. The interface provides the real-time summarization, making the system user-friendly and suitable for the both academic and practical applications. Experimental result about the audio. The experiment result shows that the transcription time increase the linearly with the audio duration. However, the summarization time remains the relative stable. The demonstrate that the chunks enable scalable processing of the audio files up to approximately 1 hour in a length. So experimental result of the video and YouTube. For video files, the audio extraction and transcription contributes the most processes time. In case of a YouTube videos, using the pre-generated transcripts sufficiently reduce the processing time and making the system 3 or 4 times faster. The highlights the advantages and uh, existing resources. So level gaining the resources, existing resources are a level up. So key findings of this, the system efficiently summarizes the content from the all support input types. The Gemini Pro consistently outparts the BART for the long transcription, and overall the system reduces the content consumption time and improves the accessibility and learning efficiency. These are the limitations. Despite its effectiveness, the system has certain limitations. It supports file up to the 200 megabyte and duration up to the 1 hour. Currently, the only English language content it supports due to the computational and the memory constraints. The future work regarding this, the future enhance the include adding a multilingual speech recognition, cloud-based processing, and the support for the longer video. We also plan to implement the automatic language detection and translations to make the system globally applicable. And this is the conclusion part. In conclusion, the research presented the AI-based framework for a summarization of the audio, video, and YouTube content by integrating the speech to text, the conversation with the transformer based summarization. The system provide and the efficient and user-friendly solution. Although are the some limitations, the proposed approach offer a strong foundation for the future scalable and multilingual multimedia summarization system.
How you will make it scalable? Sonali ma'am, in your conclusion you mentioned you will make it scalable. Means in what sense you want to make it scalable? Am I audible to you? Hello? Gayatri, am I audible to you?
Yes, sir, you're audible. I think Sonali ma'am isn't being able to hear you.
Yeah.
Can we move on to the next presenter in this case?
Okay.
Okay,
Okay.
sir. I'd like to move on to the next presenter, Manjunath Naik, sir, to present his paper titled Analytical Study of Clock Tree Synthesis and Clock Tree Based Design Approaches.
Hello.
Yes,
Hello.
please.
Sorry, sir. Sorry to disturb you, but I have given the virtual room E. Can you please check? My name is there, Sonali Patil, 1016 February.
Mom will let you know in a while. Until that, Manjunath sir will be presenting.
Okay, okay, ma'am.
Yes,
So my screen is visible, right?
yes, sir, your screen is visible. You may start.
Yeah, thank you. So good afternoon, sir, and the audience. I am Mr. Manjunath Naikvi, a research scholar from Dayanand Sagar College of Engineering. So I'll be here to present my paper titled Analytical Study of Clock Tree Synthesis and Design Approaches. It's basically a survey work that I have been carried out for my research. So to start up with in today's world, so we see in chip manufacturing or maybe in any hardware design, the first and foremost the part we concentrate is on the clock. So wherever we take any task scheduler or maybe with respect to systems which is operating with respect to a clock, so we concentrate on the synchronization of the task and even the making heterogeneous or homogeneous architectures in the design aspects of any core related designs. So in whenever we concentrate on this aspect of synchronization, we'll concentrate on the three primary aspects, which is performance and power efficiency and an higher reliability in terms of a device where which we are having higher frequency devices with respect to a clock. So whenever we try to incorporate this design activities, so with respect to these three parameters, it is essential for us to look for the clock distribution network. So the work more emphasizes on the clock tree network. Okay, so what are the key challenges that we face so in today with respect to a clock? So maybe a larger die area where we focus on the nanometer technologies as part of the design activities. So whereas we allow a higher frequency of our operations, if it is only a normal chips, then it will be around 200, 300 megahertz. Maybe if you will go for higher performance devices, it might go to up till 1G, 2G, and all. How to handle the clock with respect to this in a higher frequency? That is what it's a concern about. Whenever we reach
ಬಾಟಲ್ ಬರ್ಬೇಕಲ್ಲ ತಗೊಂಡು
from the core part of the clock to the extreme ends of the devices, so we feel a lot of aggressions on the clock networks. So we also concentrate on the power constraints
ಏನ್
and
ಮಾಡ್ತಿದ್ದೀರಾ
uh,
ಶಾಲಿನಿ ವಾಟ್ ಯು ಆರ್ ಡೂಯಿಂಗ್
I think other participant can mute
Fatima,
yourself.
Fatima, can you please mute?
So
Yes, yes.
yeah, so this will results in the with respect to the variations in PVT. So power, I think process variations and then voltage as well as the temperature. So according to the research says that around 30 to 50% of the chip power is based on the components what we use it on the hardware. So this will cause us potentially in the routing congestion as well as the timing closures. So, what are the key factors that we concentrate here? Basically, on the clock skew, where we have to minimize the clock skew in the path, and even the second part we concentrate on the insertion delay, where we can have the reduction in the latencies, and we concentrate on the slack violation. So. Maybe when we have the clock just generating from the origin and capturing time, so if it is taking more time, then we'll have a lot of less slack. And also there are other aspects like jitter, where it will be based on the noise as well as the crosstalk. So now looking into all these aspects, it's very efficient for us to design optimized clock tree network for this. So, what are the case studies will specify? By looking into the recent interventions where we used the existing devices with respect to H3 device, uh, we have a lot of interpretations where we use trade-offs between an H3 as well as a spine-based structures in the first paper, where which is having clock power reduced by 30 to 56%. But we have some tight bound on submicron technology, sub 10 picoseconds technology that will be bounded insertion latency in this paper. So coming to the other paper, we have multi-source history. They have used around. We have achieved. I think as part of the literature, 32.8% of the clock reductions, and then 30% skew reductions has happened, and overall of around 28% of the clock latency will be optimized. So the next paper that has been the recent 2024. So we have a latency load tree where we had the reduction in the skew, latency, and scalable clock distribution network. So which is almost we approximately reduced the latency of around 20% with the clock skew of around 15 picoseconds. And in the 2025 recent year, so the iterative clock tree synthesis has reported around 35 to 40% of the reduction in the clock skew. And we have NBTI aware symmetric buffering method, and then clustering mechanism also, which will be given approximately around 25% of the aging effect, which is causing an effect on the skew. So that is what we have observed in the case studies. So looking into this, we have a lot of topologies within the clock distribution network. So we have symmetric clock tree and as well as a mesh based, where we in mesh based we have to manually enter the clock routings, and we need to have buffer insertions in the mesh based. But whereas in a symmetrical clock tree structures, when we define an GST or HT, so directly we can drive the buffers, and then we can make it as a standardized structure for this. So the most of the focused aspects here is clock skew, latency, and slack, jitter, as well as a power dissipation. So these are the 5 different aspects that will be key metrics that will be considered for the work for design of an HT. And what are the trade-offs that we are we focused earlier? For all 5 trade-offs, we have concentrated on the solution. So we are going to incorporate these mechanisms to overcome from that maybe skew or slack or jitter issues. So we'll use a dynamic and voltage scaling mechanism, where dynamically will change the voltage as well as the frequency of the signal, and even we incorporate on the heterogeneous architecture. And to override from the latency, we can introduce multiple pipeline stages in the clock tree structures, and we'll also incorporate multi-chip module assembly also. And we use power aware technique, where we have MBBT, where we can interpret the low power designs by incorporating low voltages, and even improving on RC variations, where the skew will affect on it, okay, where wire length and other aspects can be optimized. So coming to as an overview, so these are the 4 factors: power, skew, latency, and jitter, as you can see here. So these are the functional design aspects that we will be considering. Around 30 to 50% of the total dynamic power consumptions will happen because of these things. So we are trying to optimize our clock tree. This is a predictable and scalable solutions that we are planning to interpret for the design. So as part of this technique, so key outcomes we can expecting multi-source ST is around 32.8% of power reduction and 13% of skew reduction. And by incorporating generalized HT, we can achieve around 30 to 56% of the clock skew control. And in the hierarchical, that is a iterative CDS, we can achieve around 35 to 40% of the clock reduction. So basically, we trying to compare the existing work with respect to the ongoing work. So what we can say is, as a part of the conclusion, so we can design an efficient clock tree structures. So with respect to balanced latency and symmetrical geometry and reliable timing closure, as well as we can achieve the higher performance. So with this, I can conclude that HT and its derivative having superior scalability and robustness, and even the timing predictability over the other topologies.
Yeah. So what are your research gap that you identified for this?
So research gap is that basically I think I have not mentioned in this key slide, but I just wanted to give an overview. So the research gap is here. There are a lot of implementations are happened with respect to an industry specific tools. So we fail like we feel it is little challenging for us to obtain the key aspects where we can explore in terms of an implementation, but simulation wise we can achieve this. So that is a gap I can feel it.
Okay. So any plan for implementation?
So implementation, it requires a PDKs where we have to take it from the foundries. That is little challenging one.
Okay. Good work.
Yeah.
Thank you. Best luck.
So for
Next, yes.
presenting, yes. I'd like to call upon Shah Johan Sundaramo sir to present his paper titled From Traditional to Smart Banking Strategies for Reducing Problem Loans in Digital Account. So are you present?
So I hope everyone has done.
Yes, sir. I think sir isn't present, so we can move towards the closing remarks. Sir. Just a second.
So just a minute. I have one doubt.
Yeah, please.
Sir, yeah, my paper ID is 931. My presentation is over. So that output you told no, sir, dependent is now it have download. Can I, if you give me a chance that I can show it?
Yeah, Gayatri.
If you want to, you can. Give it, sir.
Ma'am?
Yes, you can.
Okay. Just a minute.
Yes, but be sure to make it quick because we have to move towards the closing
Yeah,
remarks.
please. Be short
Yeah.
within 2 minutes only.
Yeah, sure. So after showing if the present what if we showing through the simulation menu, sir, our paper ID is 931 AI-based traffic management system detecting emergency vehicle. So here after simulation in terminal, it shows that in how many in what seconds the vehicles have been gone through the next lane, and how many seconds the green signal have been generated, and so on in terminal. So if I start running. Wait a minute. Sorry. Just a minute. 10 seconds. Yeah, using Pygame, it is going to running. So this is what the simulation, what our project looks. So first simulation, it going to be shown normal generated vehicles, no normal generated signals. So you can see in lane 3, the signal generation of green signal generation is more because due to the heavy vehicle. And remaining similarly for other lanes also, only we have designed for the lane 3 will become the idle number of vehicles, and lane 4 will be less number of vehicles, because in one scenario itself we need to show all the features of our projects. So it takes 30 seconds to complete entire one of our main feature of our project. So during this the emergency vehicle if appear, it going to detect it and it generate automatically green signal. And here you can see that a time escalate. So in lane 1, in lane 3, the number of vehicles, how many vehicles have been shared, total 10 vehicles have been gone through the vehicle lane 3, And here also vehicles are more. So here the generation of green signal will be 33 seconds. And based on vehicle count, the green signal will be generated, sir. And
Yeah.
the vehicles where left, right, straight, down is going to taken, because I have shown in the previous previous presentation that we have designed in that such a way that we have trained it.
Good work. Good work. Okay.
Yeah.
Yeah, good work. Good work. You please continue with this, and whatever future prospects you are planning or you are trying to implement it, and then try to put it in a journal. Good, sir.
Yes.
Good work. Yeah. So you're undergraduate student?
Yes, sir. I'm still undergraduate student. We are the
Yeah.
final year students, sir. This is a final year
Good, good.
project.
Good work. Good work. And which university?
So we are from VTU University. We belongs to ATME College of Engineering, Mysore.
Yeah. Good work. Okay. Thank you. Yeah.
Thank you, sir.
So overall,
Thank you,
all the
Divya, for
papers.
the detailed
Yeah.
simulation. And now I'd like to move towards the closing remarks, sir.
Yeah. So thank you, Gayatri. Thank you, SMARTCOM team. Yeah, for providing me the opportunity to chair this particular session. Also, I extend my thanks to Dr. Nilanjan De, Dr. Amit Joshi, and my colleague Dr. Parikshit Malle for giving me this opportunity. Really, all the papers which were demonstrated, which were presented, having extraordinary quality. Some of the papers were only survey papers, but definitely they have identified a very good research gap so that they can extend it further for the implementation. And they will present, I hope they will present their paper in the future upcoming conference of our same edition, that is 11th edition of SMARTCOM in future. Traffic management, yes, excellent paper. He has done a very good job, though he is undergrad student, but his keen interest to show the implementation part is extraordinary. Then few papers were little bit good quality, and also most of the papers, 2-3 papers were survey papers. So in all, the session contains good papers, the combination of implemented papers, survey papers, and the papers also justify the conference theme, that is smart trends in computing and communication. So I would like to congratulate all the participants and wish best luck in our forthcoming edition of our same conference. I will expect that they will participate again and contribute in the research work. All the best. Thank you so much.
Thank you for your kind words, sir. I would like to sincerely thank all the authors for the excellent presentations and contributions in this session, and all the participants for being a part of this international conference. I hope this session was informative for all. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. And we'll be definitely happy to have you in the 11th version next year as well. So the presenters will be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of SMARTCOM 2026. Lastly, I would like to thank our session chair, Dr. Ramchandra Mangalkar, for chairing this session. And here is a token of appreciation to the chair on behalf of Team SMARTCOM 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, sir. Before finally ending the session, I would like to request everyone to kindly switch on their cameras for a quick snapshot of the virtual conference. Can you all please switch on your cameras?
Thank you. And also congratulate Gayatri, you managed the session very well.
Thank you so much, sir. We are now done. I'd like to end the session. You all can leave the meeting. Stay safe, stay healthy. Thank you. Thank you for attending.
All the best for future conference.
Thank you, sir.